How's it going, ladies and gentlemen? Mr. Donahue here once again. This time we're going to take a look at formal charges. So our objectives will be to calculate the formal charge on a bonded atom and to use the formal charges to evaluate Lewis structures to determine which structure is best. All right, so you have some Lewis structures here. You got three Lewis structures for the same molecule, and they all satisfy the octet rule, and you don't know which one is the better Lewis structure. What are you going to do? What are you going to do? You're going to call formal charge. All right, so formal charge, what is it? It's the charge an atom would have if all of the atoms in the molecule had the same electronegativity. So if they were to share all those electrons equally and stuff, what would the charge be on that atom? These are not actual charges on the atom. It's just helpful to pretend in order to figure out which Lewis structure would be best. So calculating it, here's how you figure out what the formal charge is. Well, the formal charge equals the number of valence electrons that atom has minus all the unshared electrons and half of the shared electrons. So if I'm taking a look at, I don't know, let's say for hydrogen. Hydrogen had one valence electron minus all of its unshared electrons. Well, it doesn't have any unshared electrons, and half of its shared electrons. So one half of, well, there's one bond here, so that's 2 electrons. So we end up with a formal charge of 0 for hydrogen. Now let's take a look at nitrogen. It had 5 valence electrons, and we're going to subtract all of the unshared electrons. Nitrogen has 2 unshared electrons and half of the shared electrons. Well, there's 2, 4, 6 electrons being shared, so it also has a formal charge of 0. Look at that. Formal charges should add up to be the overall charge of the molecule or the ion. So you can see this hydroxide ion has a negative charge. So when I add the formal charges together, they should give me a -1. Well, let's check. I got hydrogen, again, 1 valence electron minus no unshared electrons plus half of the bonding electrons, so half of 2. I end up with a formal charge of 0. So hydrogen has a formal charge of 0. Now let me take a look at oxygen. Oxygen had 6 valence electrons minus how many did it keep to itself? We'll count 2, 4, 6, and half of the bonding electrons. Well, there's one bond, so that's 2 electrons. Half of 2 is 1, so oxygen ends up with a -1 charge. Hey, wouldn't you know it, 0 minus 1 gives me that -1 charge. So how does this help us figure out Lewis structures and which one's the best one? You told me I'd call on formal charges to answer that, and so far I don't see how that's helped. All right, well, here's how. The best Lewis structure will have atoms with formal charges closest to 0. All right, so if you have an option where everything has a formal charge of not 0 and another Lewis structure where they're all 0, you go with the one that's all 0. And any negative charges will be on the one that's more electronegative. So any negative charge should be on the atom that wants to share or wants to hold on to those electrons more, right? So whichever one's more greedy for electrons, that's the one that's going to end up with the negative charge. So let's do a little practice. Let's check out these 3 Lewis structures, all for the same molecule, but they're all different. All right, well, let me take a look at nitrogen for this one. Nitrogen had 5 valence electrons minus all of the unshared electrons. Well, it's got 6 unshared electrons and half of the shared electrons. So 1/2 of 2 shared electrons, which would give me a formal charge of, I don't know, what's that, -2? So nitrogen's got -2. So let me take a look at carbon. Carbon had 4 valence electrons. It has 0 unshared, and it's made 4 bonds. So 1/2 of those 8 electrons puts a formal charge of 0 on that carbon. And then sulfur, let's take a look. Sulfur had 6 valence electrons minus, it only kept 2 to itself, right? Only kept 2 to itself, plus half of the shared electrons. We got 6 shared electrons there. So we end up with a +1. And then, hey, look, -2 plus 0 plus 1 gives me the -1 charge. So I can check my math that I did that correctly. So now if I take a look, nitrogen -2, carbon 0, and sulfur +1. All right, well, let's continue on down the road, right? So in this one, nitrogen, again, 5 valence electrons minus, it has 4 electrons it kept to itself, plus half of the bonded electrons, which is 2. So now in this one, nitrogen has a -1. Carbon, same deal. It's 4 valence electrons minus, well, it didn't keep any to itself, and half of the shared electrons would be 4. So it ends up with 0. So nitrogen here has a -1. carbon has a 0. And let's check out sulfur. Here again, 6 valence electrons minus, it kept 4 to itself, and half of those 4 shared electrons would be 2, so it equals 0. So again, there you go. Sulfur ends up with the 0. All right, and the last one to take a look at, nitrogen again, 5 valence electrons minus, 2 it kept to itself, and half of the 6 shared electrons. So in this one, nitrogen ends up with a formal charge of 0. Carbon, same process, 4 valence electrons minus, none, excuse me, none that it kept to itself, and half of the shared electrons would be 4. So carbon, again, has a formal charge of 0 in this one. And let's take a look at sulfur. Sulfur, again, had 6 valence electrons minus, it kept 6 to itself. And now we want half of the shared electrons, which would just be 1 because there's 2 shared electrons. So sulfur ends up with a -1 charge on this one. So let me clean this up a little bit. I think, all right, now I figured out all these formal charges. Which structure is going to be the best? Well, it's definitely not going to be this one because the rest of them have formal charges closer to 0. Here, nitrogen had a -2, and the other ones, it's only -1 or 0. All right, well, now which one should end up with the negative charge? Should it be this structure or this structure? Well, the difference is in this one, nitrogen has the -1 charge, and in this one, sulfur has the -1 charge. So now it's just which one is more electronegative. And if memory serves me right, I believe it's nitrogen, which would mean that this is our best Lewis structure. So you go, all right, this is going to be what we see in reality most closely, as opposed to the other Lewis structures. So this is going to be the best Lewis structure. So try it out. Which structure is better? Pause it. Try it yourself. I dare you. All right, well, welcome back. Again, same process. All right, let's take a look. Hydrogen, carbon, nitrogen. Hydrogen, there's 1 valence electron minus 0 that it kept to itself, and half of the bonding electrons, well, there's 2 there, so half of that is 1. So here, hydrogen ends up with a formal charge of 0. All right, carbon, 4 valence electrons minus, well, it didn't keep any for itself, and then shared electrons, well, it's sharing 4 of them, so half of that would be 2. So here, carbon has a +2 charge. And then let's take a look at nitrogen. 5 valence electrons minus, well, it kept 6 to itself. And it has 1 bond, so half of the 2 electrons would be 1. So here, nitrogen ends up with a -2 charge. All right, well, let's take a look at this one. Again, hydrogen, 1 valence electron minus, none that it kept to itself, and half of the bonding electrons, which would be 1. So again, hydrogen in this one also has a formal charge of 0. Now carbon, 4 valence electrons minus, well, it didn't keep any to itself, and it made 4 bonds, so half of all those electrons would be 4 electrons, which gives me a formal charge of 0. And then nitrogen, last but not least, 5 valence electrons minus, well, it kept 2 to itself, and it made 3 bonds, so that's going to be half of those 6 electrons is 3. It has a formal charge of 0. So we're looking at 2 different Lewis structures. One, all the formal charges are 0, and in the other, that is not true, right? Carbon has a +2, nitrogen has a -2. So which Lewis structure is best? It's going to be the one where they're all closer to 0. It's going to be that one. All right, one more. All right, welcome back. All right, try it. Nitrogen, 5 valence electrons minus, it kept 6 to itself, right? 2, 4, 6, and half of the bonding electrons, well, there's 2 there, so half of that is 1, which means nitrogen has a -2 charge. All right, same process, but for carbon. Carbon, 4 valence electrons, normally minus, it didn't keep any to itself, and it made 4 bonds, so half of those 8 electrons would be 4. So here, carbon has a formal charge of 0. And then oxygen, 6 valence electrons minus, well, it kept 2 to itself, and it made 3 bonds, so that's 6 electrons. Half of that is 3, and we end up with a +1 for oxygen. So -2, 0, -1. Or +1, sorry. All right, looking at the next molecule. Again, nitrogen. We're going to have 5 valence electrons minus. Well, in this instance, it kept 4 electrons for itself, and it made 2 bonds. So we end up with a -1 charge, formal charge on that nitrogen. Carbon, it's going to look the same. It's going to be 4 valence electrons minus, none that it kept to itself, and it made 4 bonds. So its formal charge is 0 in this one as well. And then oxygen in this one, we got, all right, 6 valence electrons minus, well, it kept 4 to itself, right? You can see those 4 right here, and it made 2 bonds. So now its formal charge is going to be 0 as well. So hopefully you can see how this one is already better than the one before, because everything is 0 except for nitrogen, and the previous one was not like that. All right, last one. Nitrogen, 5 valence electrons minus, well, it kept 2 electrons to itself and it made 3 bonds, so its formal charge is 0. Carbon is going to look just like all the other ones. 4 valence electrons minus, no electrons kept to itself, and 4 bonds, so its formal charge is 0. And then oxygen, 6 valence electrons minus, well, it kept 6 to itself, right? 2, 4, 6 electrons it kept to itself, minus the 1 bond that it made, and you end up with -1. So now the real big difference is which one should have this -1 formal charge, right? We can eliminate this one because the formal charges are too high. The other options give us lower formal charges, or formal charges closer to 0. Now, which one's more electronegative, nitrogen or oxygen? The short answer is oxygen. So because oxygen's more electronegative, it's going to be the one that hogs those electrons more, so it should be the one that gets the negative charge. So this is the best Lewis structure of those 3. So summarize, can you calculate the formal charge on a bonded atom? Can you evaluate Lewis structures using formal charge to determine which is the best? I don't know. Well, that's it. Yeah, hope you found that helpful. We'll see you in class. Okay, bye.